Sci Access, May 11, 2024. Teaching Physics with Disabled Learners, a review of the literature. Dr. Erin Scanlon, Dr. Jacquelyn J. Chini.
Hi, everybody. Thanks for that introduction, Anna. As they said, my name is Erin Scanlon. I use she, her pronouns. I am an assistant professor in residence at the University of Connecticut. Jackie, unfortunately, is not able to be here today. She is in the process of moving. So I'm going to be presenting about teaching disabled learners in physics specifically. So like I said, Jackie and I are the project team. So a little bit of background. We were approached by the American Institute of Physics because they were writing this textbook shown on the right-hand side of the screen called the International Handbook on Physics Education Research. They specifically asked us to write a chapter about how we can support disabled learners in the physics classroom. Our goal in the synthesis was to synthesize and critique the existing literature about how instructors can teach physics courses in ways to better support disabled learners. And our intended outcome was to move physics communities towards social justice and equity of access, support, and inclusion of all learners, regardless of their disability status. I'll share this link again at the end of the talk, but if you're interested in the book chapter, the link on the lower left-hand corner will take you to the book chapter. And our book chapter was chosen as the free version, so you can download it for free using this link. Before I get into a little bit about our methods for the literature review, I would like to start by talking about two prevalent models of disability. If you look at the picture on the left-hand side of the screen, you'll notice that there is a person and they're wearing a shirt that says the problem. Additionally, there are arrows pointing towards them labeled as the problem. So in the individual or medical model of disability, the person who has the disability is seen as the problem. They are something that needs to be changed or remediated, and the burden of that change falls to the individual, usually through medical technology or medicine or things in the medical field. However, on the right-hand side of the screen, we have the society or social model of disability. In this case, the person is no longer wearing the shirt that says the problem, and instead we have arrows that are pointing away from the person and are labeled as barriers. So in the social model of disability, disability really is about the interaction between a person, their impairment, and the environment. So in the social model of disability, it is in the environment that has to change rather than the individual. Jackie and I take this framing in our research because it is helpful for us as instructors, right? We as instructors have control over the environment, and we can change the environment to be more inclusive and accessible to the widest range of people possible. So I'm going to move forward utilizing the social model as a lens for our literature review. So a little bit about our methods. So we searched many different physics journals, including the American Journal of Physics, the Physics Teacher, Physics Education, and Physical Review of Physics Education Research, and had a couple of keywords. To show you about our literature review process, we started with about 205 articles originally. Then 177 of them were focused specifically on the post-secondary setting. 132 of those were focused on physics. 123 had a disability focus. 104 had a teaching and learning focus. And then finally, 93 of those were published for a final of 66 where teaching and learning was discussed. So we found 66 articles across the literature that kind of fell into those three different categories. So that's our process. And through that process, we found major findings for both practitioners as well as researchers. I'm going to focus primarily on the findings for practitioners with a few of those researcher findings at the end. So in this diagram, I'm showing you the 6 different categories of findings that we came across. Number one, we found findings for the laboratory setting and how we can change laboratory devices to be more accessible. We found virtual simulations that can be used in lieu of hands-on experiments. We found suggestions about direct instruction or how we can lecture in the classroom. We found recommendations about demonstrations and how you can physically demonstrate a physics concept in the physics classroom. We also found one about textbooks and what we can do to make textbooks more accessible. And then finally, there were some general instructional practices. These were things like how to use universal design for learning, as well as some more theory about disability in the sciences. For today, I don't have time to talk about all of those different things, so instead I'm going to focus on those first three. So let's turn our attention first to the laboratory setting. In the laboratory setting, we found things like one category of studies we found were modifications to existing equipment. Things like adding raised lines to provide access to diagrams and graphs, using tactile representations of laboratory equipment, so like putting Braille on there, for example, or using modification of measurement readouts. So things like a talking calculator or other kinds of data acquisition tools that can be read aloud for the person rather than having to use our eyes to see it. Another category of findings was about accessible laboratory tools. So what are the tools that we can use specifically to make the environment more accessible and inclusive? For example, you could create a right-hand rule device. And if you're not familiar, the right-hand rule is a physics rule where you use your right hand to see vectors. And some folks don't have the dexterity or a right hand in order to utilize the right-hand rule. So it's an artificial right-hand rule device. Another one is Access Scope, which is an application that allows students to remotely access and operate a microscopy workstation. So this is a way to provide meaningful access to experiments without a person needing to be physically there or to physically operate the workstation. And then finally, we found methods and tools for specific experiments, specifically things like experiments where students could use wheelchairs on ramps with a motion detector to understand the basics of motion and kinematics. So a lot of the findings were specifically about the laboratory setting, which is wonderful that we have these access tools to utilize in the future. We also can turn our attention to virtual simulations. Before I get into the findings, I wanted to note that there are many reasonable and appropriate reasons why an instructor would want their students to engage with a virtual simulation of an experiment or a concept instead of a hands-on laboratory. Maybe the individual is out sick, or maybe the individual the laboratory doesn't provide access for the individual and thus they can't work with the other kinds of experiments. Or you want to provide an opportunity for students to relearn and refresh what they learned in the lab. Right? There are many reasons to use virtual simulations. And I wanted to point out that in the literature, there were a lot of research focusing on the accessibility tools of these virtual simulations. Things like making sure that they are screen reader compatible, alternative keyboard compatible, and allows for alternative navigation access, that there are auditory descriptions of the simulation design scenarios, meaning like an audio description of the different pieces in the simulation, as well as they were utilizing data sonification, where you take data and turn it into sound that individuals can hear. I wanted to point out that there are 47 accessible PhET, which is physics education technology simulations that currently exist. And I've included a link to them on the slides if you're interested in checking those out. And then finally, I'd like to point out the direct instruction findings. So again, this is talking about how we can lecture in our courses. So things like utilizing tactile 3D representations to help visually describe physics concepts can be really helpful. For example, a colleague of mine, Steve Sayun at the University of Wisconsin-Whitewater, has these really interesting 3D printing templates or softwares where you can print out things like a wave pattern to show red light versus blue light, for example. So that would be one tactile representation we could use. Another one is to allow students to use the accessibility tools of their choice. We want to make sure that students are provided not only supports, but options for what tools they want to use. We could also convert all visual course material into an accessible format, such as audible or tactile formats. And one thing I wanted to point out is at the post-secondary level, many institutions use learning management systems where this conversion can be done for you automatically or with a small click. Another one is that we can use visual and tactile modalities in the place of auditory information to support hearing impaired students, right? So provide multiple options for students to access the information rather than solely relying on a single method of access. And then finally, we can use see and feel sensory focused pedagogy to provide access to demonstrations for hearing impaired students. Specifically, this example talks about a Rubens tube, which is a way of showing pressure waves and utilizes basically fire in order to show those pressure waves. So it's a really interesting experiment. Okay, so those are some of the findings for practitioners. If we look at the research side, some of the findings were things like research on understanding of disabled students in particular content areas. So they were interviewing blind students about their experiences with concept inventories, which are commonly used in physics. We can utilize universal design for learning to look at research-based instructional strategies. So my colleagues and I analyzed popular physics written curricula to identify examples of UDL-aligned practices. We can also look at research on disabled students' experiences in post-secondary STEM. So for example, some of our research identified that disabled students have challenges related to engaging with the course content and course-related anxiety. And those are things that instructors can change their course policies or course practices in order to reduce that anxiety. And then finally, there's research on instructors' experiences teaching disabled learners, things like surveying, interviewing, and observing STEM instructors. And we found that many of the barriers to using more inclusive teaching methods were dominated by financial and institutional demands. So those are some of the findings in the research space. I'd love to move on now to a discussion of some of our critiques and synthesis of the literature. So overall, there was this problematic framing of situating the students as the problem. And if we think about the social model of disability, the students aren't the problem, right? The environment that has the barriers is the problem. So we need to move away from this individual model of disability towards a more social model in our research. Throughout the entire research corpus, there was an underemphasis on supporting students with hearing impairments, emotional mental health impairments, cognitive impairments, and health impairments. So we're looking to expand our research to include a wider range of disabled learners rather than focusing on different specific kinds. There was also a lack of focus on changing the culture. We know that culture plays a really big role in the experiences of students in higher education. And instead, a lot of the research was focusing on concrete access concerns. And I'm not saying that concrete access concerns aren't important to focus on, because they are, but we also need to have additional research focusing on changing the ableist culture in higher education. Some implications for instructors. So this is a process that I'm going to suggest that instructors utilize in order to critically examine who they are supporting and who they are privileging within their courses. So first of all, we can identify those barriers. So we can critically examine our courses along accessibility and inclusivity lines. Once we have identified those barriers, we can identify inclusive teaching strategies that can lower or eradicate these barriers through universal design for learning is one tool that we could use to do that. Once we have identified those inclusive teaching strategies, we can implement them on our teaching. And these are going to be incremental changes, right? We do one more thing each semester to change our instructional practice. And then we can assess the impacts of these new strategies. And one thing that I would like to point out is a refrain from the disability justice space that says, "Nothing about us without us." So when you're doing this assessment of the new strategies, you should make sure to include and center the disabled voices in that space, because we want to make sure that we are doing what's actually going to be helpful for folks. For researchers, I have a couple implications as well. For example, I would suggest that you investigate the unique experiences of disabled students in physics programs. So what are the experiences unique to disabled students? Or we could look at what are some intersectional experiences. So intersectionality is a term that comes from the legal space, which looks at the experiences of women of color, right? So in that space, women of color can be marginalized because the fact that they're women or because the fact that they are of color. And so we can identify and investigate those intersectional experiences of our students. What is it like to be Black and disabled, for example? What is it like to be queer and disabled? Look at those experiences at the margins. Again, we can focus on students with emotional mental health, cognitive, and health impairments moving forward, as there was a dearth of that research available. We can take up suggestions of solutions of access needs and investigate their impact on diverse populations of physics learners. So because there is so much literature about concrete solutions, we can investigate the impact of those solutions on a variety of students. We can investigate the systemic changes necessary to make available time and resources for instructional development. So that involves advocating within our university structures to make sure that our administrators and superiors also value anti-ableist work and provide time and resources for that work. We can also remain attentive to community identities, especially regarding language usage, as we know that disability-specific language varies from person to person, as well as can vary over time. And then finally, we can judiciously collect disability status information and report on these findings in other studies. So there are many other kinds of studies that can occur in the physics education research realm, and we can make sure that disability is infused in those other studies as well. So not neglecting the presence of disabled learners within our research populations, and instead stating their presence and looking for the unique impacts of the different studies on disabled individuals. Some future research directions, I just have a couple of suggestions for us as a community. One would be to attend to the intersectionality of individual identities and the varying impact of disability across other dimensions of identity. This is a big place of future work for our community, as there isn't a lot of research about intersectional experiences within disability. That's not to say that there isn't any, but there is need for more of that kind of work. We can also move away from the medical model of disability, which situates individuals with disability as the problem. We are not the problem. The environmental barriers are the problem that need to be fixed. And then we can zoom out of classroom accommodations to consider how disabled individuals are able to participate within the broader physics communities. So this means zooming away from post-secondary education and looking at the workforce and professional societies and mentorship opportunities for disabled individuals, and make sure that we are investigating the impacts of those other practices. I would like to close my talk with a call to action. So after a long history of positioning disabled individuals as a burden in the physics community, it is time for physics education research to center the knowledge, skills, and experiences of disabled individuals, and to identify systemic change that will support full participation of disabled individuals in physics classrooms, laboratories, research experiences, and the broader community. Oh, my colleague Jackie wrote that quote, and I just get chills every time I think about it, because it's so important, again, that we are centering the experiences of disabled individuals rather than relegating them to the margins. I would like to thank you all so much for your attention. If you're interested in contacting me or Jackie, our emails are available on the slide. I also have a link and QR code available to the slides as well. Thank you so much for your attention, and I am happy to answer any questions that y'all have.
Thank you so much, Erin. We do have one question from Joanne, who says, we have a professor at NC State who made a neurodiverse physics class. Is there a group or consortium that can collaborate and share all of your great ideas and others too to make the curriculum better for all?
Yeah, so I'm really excited about this neurodiverse physics class. That sounds awesome. I would love to hear more about that in the future. And then yes, Jackie and I are always looking for future collaborators. And I think we did this literature review to show the current landscape of physics for disabled learners. I think our goal is to address those future research concerns that we have put there, as well as to continue to do professional development. A couple of my collaborators and I at Michigan State and at UConn recently received an NSF grant to specifically look at professional development for faculty tied together with professional development for disabled learners. So it's kind of a dual stranded thing that we're planning to do moving forward. So that's one of the established ways that we plan to move forward with this data. But please feel free to reach out to me or Jackie, and we would love to hear other suggestions of how we can move forward with this work.
Thank you. And to that point, Erin, if you're comfortable sharing your information in the community connections spreadsheet, we'll share that in the chat as well. And that'll make sure we can have everyone have your email and connect after the talk. We also have a question from Anne who says, could you please screen share again to show the virtual simulation slide briefly? I was hoping to take a screenshot.
I can definitely do that. Give me just 1 second.
Yeah.
There we go. Okay, great.
Perfect. Thank you.
I know, and one thing I wanted to point out is if you see any blue text on my screen, that indicates a link. So for example, all of those numbers there are the links to the citations that have literature about that specific thing. So this is also a place for you. If you would like to see the literature, it's there.
SciAccess. Learn more at www.sciaccess.org.